Here we're going to show how PartBuilder from CAD Enhance builds a 324-pin FPGA, an Altera device, the 10M08S384. We're going to select the Altera physical flow, which will build FPGA pins by bank. It'll organize one symbol per bank automatically. And then we're going to look at the pin report file. We get this from the Altera website. It's that we can download that file and we enter it into PartBuilder. And now we'll take a look inside the file that Altera provides, and we can see it contains all the pin names, all the pin numbers, and the special pin types and properties. And it actually contains them for every single package that this device is offered in. And PartBuilder has all the intelligence needed to extract all the pin data from the proper package within this file. And because it has multiple packages, we have to tell PartBuilder what package we want to build out of. So we're going to look at that, and we're going to choose the Altera Max10 family and the U324 package from that file, which gives us the 324 pins. And we'll save these changes. So the first thing we'll do is we'll read the pin report, and immediately PartBuilder extracts 324 pins from that file. Then we're going to run SmartFrac, which is going to create the SDL for us. And we can see it auto-detected FPGA banks for this part. And it sees 1A, 1B, 2, 3, 4, 5, 6, 7, 8. And then it tells us that it's created 9 signal match statements to match 200 pins and 15 power match statements to match 78 power pins to create the SDL template file, which we're going to take a look at next. So it created the symbol description language file for us that describes how we should build these symbols. And we can see it built one symbol for each bank, and it put the power pins on the right and the I/O pins on the left. And then it came down and built the power pin signal where it automatically figured out how to fit all the power symbols, the power pins on there. So the next step we run is map pins to symbols. And what that does is it looks at the SDL instructions that were created, and it fits the pins around the symbols. So we can see it created all those symbols for us. And now we can look what we're set up. We're set up to build for Allegro HDL, Eagle, and now we're going to enable Zukin too. And then we're going to run the create symbols step. So we'll create the symbols. It runs and it builds the files. The last set of files it shows us is the Zukin symbols. And then we'll take a look at them. We look at the Allegro HDL symbol. All the other symbols are very similar, so we can look at it just with the Allegro HDL. And we can see as I page through that we built a symbol for every bank. And with the I/O pins on the left and the VCC I/O pins on the right. And here are the power pins that it created, so SmartFrac was able to figure out how to fit all the VCC and ground pins together on the one symbol. And in less than 2 minutes, we've created a 384-pin FPGA. So let's say we want to, and that's with no effort at all. So now what we'll do is we'll open the SDL editor and we'll make a little edit. We'll put the 1A pins and the 1B pins together in one bank. So it'll make it more efficient. So what we'll do is we'll cut the 1B pins. We'll remove the start and end of symbol between the first two symbols. Okay, we'll put the 1A pins both on the left, and we'll put the 1B pins, we'll put them both on the right. And then we'll place the power pins together, the VCC-IL1A and VCC-IL1B, and then we'll put a balance symbol sides, which will separate the power pins from the rest of the pins together. And then we'll add to the 1B underscore to the name here of the symbol. And then we save this file, so we can see we have the 1A, 1B power. We save this file. It tells us that it wants us to create a new name so it doesn't overwrite the template that SmartFrac created. So we just call it symbol new.sdl, and then we run it and take another look at what the symbols look like. So instantly it created the symbols for Allegro, OrCAD, and Zukin again. So we'll take a look at the new pins we create, the new symbol, first symbol, where we put the 1A pins on the left and the 1B pins on the right. The I/O pins are on the bottom and the power pins are on the top. So with that one little edit, we were able to control how the symbol was built very easily. So with just that little demo, we can see how powerful PartBuilder is when it comes to building FPGAs. This was a smaller device, but the process scales to fit a device with 4,000 pins if it needs to.